All right, guys, here we go. You guys ready? All right, Miss Pina, let's focus. Okay, so here we go, guys. So these are just the same as like what you had on Delta. They're a little tougher only because this doesn't give you feedback immediately until the very end. So let's talk about them. Let's see how we do them. Let me know which ones you want me to skip. If you don't want me to skip any of them, well, then we'll do them all. So what's my first move for trying to solve this? Arc cosine. So you have 7x equals arc cosine. If you want to put plus or minus in the front, that's fine. Plus 2 pi n. And then you look at the unit circle. And cosine is 1 in only one location. Because it's 1 in only one location, you only need one equation. So then you write 7x equals, you can either choose to write 0. If you're not comfortable with 0, I can also choose which one. Starts with number 2. 2 pi, whichever one you want, but this will give you that 2 pi. See, 0 plus 2 pi n. If n equals 1, then you got an answer of 2 pi. The n is just how many cycles you've done, because the period is 2 pi. Well, it's the period, not 2 pi. The period is 2 pi over 7 when I divide by 7. How did I get rid of that 7 there? Divide by 7, divide by 7, divide by 7. X equals, you still have a 0 there, plus 2 pi n over 7. So the period is 2 pi over 7, so that's why that 2 pi 7 is there at the end. All right, so what are my x values? Well, one x value is 0, because it's telling me to look between 0 and pi over 2. And then the other x value is 2 pi over 7. Cool or not cool? If I were to add another 2 pi over 7, or if I were to make that n equals 2, then I would get 4 pi over 7. Chav, how do I know that that's not in the interval? Let me show you why. If this 7 were an 8, 4 pi over 8 would be a half. Yes or no? But because the denominator is a 7, 4/7 is larger than a half. That means half a pi. So 4/7 is larger than half a pi, so that means 4 pi over 7 cannot be it. Do you see how we're doing it, guys? And if you don't trust that logic, then go ahead and use your calculator and you can just type in pi over 2, see what that digit is. Type in 4 pi over 7, see what that digit is. And you'll see, bless you squared. And you'll see that the 4 pi over 7 is larger than pi over 2. All right, let's go to the next one. Yeah. All right, so this one. Cosine 9x equals 0. What's my first move? Yeah, inverse. 9x equals arc cosine of 0 plus 2 pi n. If you're in the habit of putting plus minus, that's fine. Go ahead and do that. Arc cosine of 0 on the unit circle. Cosine is 0 in 2 locations, so that's how I know that I'm going to have 2 equations. Cool or not cool? Okay, so I'm going to write my first one. I'll write 9x1 equals, the first one happens at pi over 2, if you're going counterclockwise, plus 2 pi n. Where does the second one happen at? Perfect. So I'm going to change my color just so you guys can know that I'm doing a second equation. Equals 3 pi over 2 plus 2 pi n. I'm going to go back to the red. I'm going to divide by 9 or times it by 1/9. You guys seem to like to multiply, so I'm going to go ahead and multiply by 1/9, the reciprocal. X1 equals pi over 18 plus 2 pi n over 9. Notice that the domain is between 0 and 2 pi over 9. So I'm not going to be using this 2 pi over 9 because I would already be over the domain. Does that make sense? Same thing with the sky blue one. Divide by 9 or times it by 1/9. Times 1/9 times 1/9. X2 equals 3 pi. Actually, you know what? Here's how I do it. 3 goes into 9 3 times. 3 times 2 is 6. So pi over 6 plus 2 pi n over 9. Did everyone see how I got the pi over 6? Okay, just in case you don't want to say, here's what I did. Bless you. Oh, that one was a good one. I bet you feel amazing. 3 goes into 9 3 times, see? And then I just 3 times 2, just for that. When you're multiplying, don't forget, don't multiply the 2 pi n by 1/3. You're still multiplying 2 pi n by 1/9. Okay, answers. Answers, well, I'm not doing the 2 pi 9. I'm not adding to it, so don't add. So then that means pi over 18 is an answer, and pi over 6 is an answer. So there it is. Yay or nay? Okay. Do you guys want me to do this question? It's similar to what you had on Delta on this one, but if you guys want me to do it, I'll do it. Yeah? Okay. The only way, so I have cotangent x equals negative square root of 3. And I'm going to go x equals arc cotangent of negative square root of 3 plus pi n. Bless you, bless you, bless you, bless you. The only way to get a square root of 3 is if you have a negative square root of 3 over 2 in the numerator and a positive half in the denominator, or if you have a positive square root of 3 over 2 in the numerator and you have a negative half in the denominator. I do not have to worry about both, because if I add pi, I'll get the other answer. So tangent and cotangent, you're only going to have one equation, or arc cotangent. So we're going to say x equals, let's see, where does this happen? Because that's the one that you hit first. That happens in quadrant 2, bam, right there. And cotangent is x divided by y. So that coordinate there is negative square root of 3 over 2, comma, positive half. And I know some of you are like, Chav, why don't we do this one again? Because that one is this one right here. And notice that if I just add pi, that's a pi right there, that's a straight line, I get the other one. So that's why this only needs one equation also. Cool or not cool?
Question, how come you didn't convert it to tan?
That doesn't matter. You can. If you want to convert it to tan and say tan, arc tan, oh look, I don't even have an arc in there, -1. Arc tan of 1 over negative square root of 3, that's fine too. But then you would reverse this, and it'll be the same thing. You'll get the same answer. Because that's still a y value divided by an x value. See? So you'll get the same answer. It doesn't matter how you do it. Yeah. Remind me, guys, when I make a little mistakes like that. We need to have proper notation. Okay, so that happens at, what's the radian? 5 pi over 6 plus pi n. Actually, and yeah, there's nothing in front of the x, so you're just going to get those answers. X equals 5 pi over 6. I'm going to add pi to it. You probably already know it, though. 6 over 6. 6 plus 5 is 11 pi. And look, there's that other answer anyways. So 5 pi over 6 and 11 pi over 6. Is this getting easier, guys? Okay. Is this helping? Okay. So here's the question that I saw a lot of you get wrong on delta. It looks like you guys don't know what to do with that square. All right. So guess what? On this one, I am going to turn it into cosine squared. So I'm just taking the reciprocal. Cosine squared x equals the reciprocal of 1 is still 1. And then a side note. Cosine squared x equals, giant parenthesis, cosine x close it squared. That's what it means. Don't put the square after the x, because then that means that the argument is squared. The x is squared. That's not what that means. How do I get rid of the square? Take a what? Square root. Square root, square root. Cosine x equals, the square root of 1 is 1, but say plus or minus 1. And that doesn't have anything to do with plus minus in front of the cosine when we do our cosine. The plus minus 1 comes from, that's the square root of 1. -1 times -1 is 1. And positive 1 times positive 1 is also 1. Cool or not cool? On the unit circle, where is cosine positive or -1? At pi, 2 pi, 3 pi, 4 pi, depending on my interval. Notice they say negative pi over 2 to 3 pi over 2. Negative pi over 2 is right here. If I go counterclockwise, so one answer is 0, I keep going. Another answer is pi, I keep going. And then I get to 3 pi over 2, but then I check to see if it's in my domain. It is. Oh no, it's not. The 3 pi over 2 is not an answer because cosine is not 0 there. We're looking at where it's 1, right? 2 pi is an answer. Why did I write 3 pi over 2? Yeah, you got to call me out on it, guys. 2 pi. But 2 pi is not an answer. That's what I meant to say. 2 pi is not an answer because you got to stop at 3 pi over 2. Does that make sense? Yeah, so you only have 0 and pi. Yeah, I'm running on super little. I'm sure you guys are the same. Was this week a hard week for you guys? Yeah, this, honestly, if I'm being honest, I think besides AP week, this is probably the most sleep deprived week I've been in like the last 2 years. So if I fall down and paramedics come in, just tell them that I'm just sleepy. No, I'm good. I had coffee. I've had 3 cups of coffee. So right now I probably had like 200 milligrams of caffeine. So I'm going to add more, hopefully. I won't have a heart attack, will I? Okay. Okay. All right. Here we go. Yeah, that might be too much, but we'll see.
It was a one-time thing. Don't worry, Joe.
Was your heart beating super fast?
No, I felt fine.
Well, yeah, you were all high on caffeine. All right. So how do you do this one? So some of you guys have been canceling the 8 sine x. Don't do that because you're going to miss out on some answers. So I moved it to the left, and then there's nothing on the right-hand side, so that means it equals 0. So what do you do next? factor out an 8 sine x. So this is just like algebra. If your algebra skills are lacking, you might have a hard time here. If you factor out an 8 sine x, you're going to have cosine squared x minus 1 equals 0. So then I say, well, the only way that's going to be 0 is if 8 sine x equals 0. Well, if I divide both sides by 8, that means that sine x equals 0. On the unit circle, that happens here and here. So that looks like, look at the domain, negative 2 pi. Negative 2 pi is right there. And put a 2. 2 pi. And so let's see, negative 2 pi. And then it goes all the way to 0. So that means, so negative 2 pi, negative pi, and then back to 0. So there it is. No, well, okay. Am I going too fast? Yeah. So yeah, I'm going to start over. Okay, ready? If I go clockwise, so here's an answer. Everyone knows I'm at 0, right? If I go like this, I'm going clockwise. Chop, why are you going clockwise? It tells me from 0 to 2 pi, so I guess I should have started at negative 2 pi, but I want you guys to see it. If I go clockwise, that's negative pi. Do you guys see that? If I keep going clockwise, that's negative 2 pi. So I'm only getting answers between negative 2 pi and 0. So negative 2 pi is an answer, negative pi is an answer, and 0 is an answer. But don't worry, we're still going to talk about this right here. That you actually already did right here in this one. But I'll show you again, just in case. So look at this. So I'm going to write, well, cosine squared x minus 1 could also be 0. I move the 1 to the other side. Cosine squared x equals 1. I take the square root. Cosine x equals plus minus 1. OMG, we had that earlier. We had that earlier right here. Look at that. And what answers did we get on that one? 0 pi and 2 pi? Well, that's because of that, right? So we got 0 pi. But this time I'm in this domain, negative 2 pi to 0. So it's the same values. X equals 0, negative pi, and negative 2 pi. I guess if I'm writing them from least to greatest, it's negative 2 pi, negative pi, and 0. What's up?
Start back from where you put 8 sine of x times the cosine squared x minus 1 to 0.
Yes. So I factored out the 8 sine x. Why did I do that? Because I saw an 8 sine x here and I saw an 8 sine x there. So notice that if I distribute this, I would get this 8 sine x cosine squared minus 8 sine x. See? So all I'm doing is distributing, guys. It's just like if you had 8xy squared minus 8x equals 0. What would you do? 8x parentheses y squared minus 1. It's like saying that.
I meant like how did you get to 8 sine x equals 0?
Okay. So now we use logic. So don't be a robot. The only way, see how it equals 0? The only way you can equal 0 is if the expression 8 sine x equals 0. Because 0 times anything is 0. So I set the expression 8 sine x equal to 0, and then I said, well, I divided both sides by 8. I guess you don't have to do that if you don't want to. Then I got sine x equals 0, and then I said, where will sine x be 0? Sine is a y value. And I said, well, you're 0 at those black dots there. And then I counted, I went clockwise, because it's negative, and I got all those negative values, negative radian values. Does that make sense?
Yeah, and why couldn't cosine squared x minus 1, why couldn't that be 0?
Yeah, it can be 2. So I said, what if this expression is 0? So there's my cosine squared minus 1, and I equal it to 0. And then I moved the 1 to the other side, and then I took a square root, and I got this guy in rectangle, cosine x equals plus minus 1. And it just so happens that it's going to be those same black dots, because that's where cosine is a positive 1 and a negative 1. Do you see that? Yeah, make sure you use logic. If you use logic, you'll never be wrong. Do you guys find math class to be the easiest class because it's just logic? No, for reals, guys. I don't know why people, every time I go to these teacher workshops and, sometimes I lead one and sometimes sometimes I present, sometimes I'm just a spectator or whatever. I always find that there's teachers that are so scared about math. And I'm like, why? It's the easiest subject from all the subjects. Nothing's abstract. Unless you take abstract math, and that could be. But that's at the university and only for math majors. If you're not a math major, you'll never take complex analysis, row analysis, and all that, discrete structures. But at the high school level, all this is just logic. Doesn't it all make sense? Yeah, if you've been going up since Algebra 1, all this, it just makes sense. It's all logic. It's just a little puzzle. So math should technically be the easiest class. Everyone should have 100 average because it's just logic. So, all right. Here we go, guys. This is the only one. This is the only one that we have not talked about, but you still know enough to figure it out because I'm about to give you the information. So on this one, it's okay to be a robot temporarily. We are going to derive this equation from scratch in about 2 weeks because we're still about 2 weeks away. A week away if we're fast enough. Sine 2x is equal to 2 sine x cosine x. If you want to Google this, this is called a double angle. We will derive this from composite argument properties. We're not there yet. We're about a week away. Well, if we're fast enough, we're a week away. If we're slow, then we're about 2 weeks away. Are we okay? Yes. Sine 2x is equal to 2 sine x cosine x. I know, you've never seen it because we haven't gone over it. This is the only question that's like that. The only one. Yeah. If you Google it, Google. You can Google double angle. You might see some half angles as well. But don't worry, we will cover this next week. I'm not a fan of being robots, so we will derive this from scratch. Are we okay? All right, here we go. I'm going to replace sine 2x with that expression. 2 sine x cosine x equals negative 15 cosine x. I'm going to set up an expression, so I'm going to move this to the left. And if I move that to the left, I have nothing on the right side, so it's going to equal what? 0. So 2 sine x cosine x plus 15 cosine x equals 0. The next move, I see a cosine x on this product. I see a cosine x there, so that means I can factor out a cosine x. 2 sine x plus 15, close it, equals 0. And then you just use logic. Don't be a robot. The only way this expression will equal 0 is if cosine x equals 0. That's not the only way. There's another way, right? If that expression is 0 as well. I draw my unit circle and I say, where is cosine x equal to 0? Well, cosine x is 0 on the vertical axis. What is that first radian? Pi over 2. What is that second radian? 3 pi over 2. And then I say, well, look, there's also this one. So then I set that expression equal to 0. And I know some of you are probably super smart and like, well, Chop, that's why are you even doing that? Sine x will never be 15 over 2. You're right. Or negative 15 over 2. I'll show everyone else what we're talking about. Move that negative 15. Move the 15 so it turns to a negative. 2 sine x equals negative 15. Divide by 2. Sine x equals negative 15 over 2. This will never happen. So I'm going to put a slash for the equal sign. Sine x, look at your unit circle. Sine x will always have values between negative 1 and 1. That negative 15 over 2, what's that? Negative 7.5? That will never happen. Does that make sense? Yeah, in case it doesn't make sense to you, if you were to graph y1 equals sine x, it would look like this. It would go, it'll be a wave. The highest it ever is 1. The lowest it ever is negative 1. That value here, this number is negative 7.5. You'd be way down here. You'd be way down here, negative 7.5. See, they don't touch. They never intersect. Okay. So there it is. These are my only answer. Why does UH write them like this? It's probably a coding thing. It's probably easier to code it. They probably use LaTeX or something, the programming language to write all these things. Okay. All right. You guys ready for this one? Yeah, don't worry. This is actually the simplest one. All question 7s, and I hate to say that because I feel like we're cheating the systems. All question 7s, it looks like to me, if you see this, it doesn't matter what number you see. If you see this, it doesn't matter what you put in front of it, as long as these numbers are the same. As long as these numbers are the same and they're both squared, it's always going to be, well, where is sine equal to cosine, the magnitude? Because you don't care. They're being squared, so you don't care about the sign. What's a negative number squared? It turns into a positive. So all you care about is where sine and cosine have the same magnitude. So I'm going to write that. Where sine theta and cosine theta have same magnitude. That just means number. Oh, I just saw a mosquito. Get out of here, mosquito. Bless you squared, bless you cubed. Good. I saw that coming. Join the dark side. Guys, okay, I'll stop. We have cookies. All right. Sine and cosine, I need them to be the same magnitude. I don't care about the sign, guys. I just need them to be the same value. That's what I'm talking about. I just need them to be the same value. Negative square root of 2 over 2, square root of 2 over 2. See? Negative square root of 2 over 2, comma, square root of 2 over 2. And square root of 2 over 2, comma, negative square root of 2 over 2. So all of those, Chavez, but why? I want you, yeah, look, check it out. I don't want to make robots, so let's talk about why really fast. Really fast. If I take my calculator, here's what I'm doing. I'm literally just going to type this on my calculator, the 2 sine squared x. But I'm literally going to put the 1 in quadrant 2, 3 power 4 because the x and y have different coordinates. So look what happens. If I type in, so here it is, it's in radian. I'm going to go 2, and I'm going to open a parenthesis. I'm going to put sine, and I'm going to put 3 pi over 4. 3 pi over 4. We know that sine is positive in quadrant 2, and I'm going to square it. Oops. Yeah, I haven't squared it yet. Boom. So there it is. Enter. Look how I get that value. You get a 1. Are we okay so far? Look if I do the other one. 2, open parenthesis, cosine 3 pi over 4. Close it, and then close it again, and then put a square on it. Look how I get, look at that. I get a 1. We don't care about the sign because I'm squaring it. When you square a negative, you know, square root of 2 over 2 squared, well, that turns into a 2, that turns into a 4, you get a half. 4 over, 2 over 4, that's a half. And because I'm squaring it, the negative goes away. When I do the same thing to this number, you're going to get a half again. Half times 2 is 1, half times 2 is 1. That makes sense, guys? Yeah, it's always going to be like that, question 7. So there's a free one. So all you got to do is look for where you're under the denominator of 4s. Here it is, because it's between negative pi and pi. So look for where the denominators are 4s, because it happens at 3 pi over 4, 5 pi over 4, 7 pi over 4, pi over 4, and it's going between negative pi and pi, so as long as the denominator is 4. Yes?
Where did we get the pi over 4 denominator?
All of them are, this is pi over 4, this is 3 pi over 4, this is 5 pi over 4, this is 7 pi over 4. That's if you're going between 0 and 2 pi. But I'm not going between 0 and 2 pi. I'm going between what and what? Negative pi and pi. Do you guys see that? So you got to get the negative 3 pi over 4 and negative pi over 4. All right, here we go. You're going to need algebra, but basic algebra, not extreme. This is similar, so I'll write it down, similar to 2x squared plus 11x minus 6 equals 0. Are we okay? We're going to do the guess and check method. So I'm going to write guess and check. If you want to Google any of these terms. And I'm going to write parentheses, equals 0. The only way to get a 2x squared, well, at the high school level, we'll let your professor mind blow you guys. But at the high school level, the only way to get a 2x squared is to get 2x times x. Are we okay with that? Now that 6 has many ways that you can get negative 6. You can do 3 times 2 or 3 times negative 2. You can do 6 times 1. Let's see which one matches. I'm going to look. I see a 2 there, so I'm going to put a 3 over here and a 2 over here, and let's see if that works. 2 times 3 is 6. 2 times x is 2. And the difference between 6 and 2 is not 11, so it's not going to work. So I erase it. Yeah, so then what else do I try? 6 and 1. I'm going to put the 6 here and the 1 here. And check it out. 2 times 6 is 12. 1 times x is 1. And the difference between 12 and 1 is 11. So it's that one. You got to choose which one's positive. You want the bigger number to be positive. So the plus goes there and the minus goes there. Do you see how we did it? There's also another way. If you don't like it, it's called the AC method. Swing by during lunch or after school and we'll teach you that real quick. All right. So now let's find out from algebra which one of these work. X could equal negative 6, and if x equals negative 6 plus 6 is 0. 0 times anything is 0. Or x could equal a positive half. Child, how did you do that so fast? Move the 1 to the other side, divide by 2. If you want to see it, I'll go ahead and show you. 2x minus 1 equals 0. 2x equals 1. X equals half. So from now on, you can just do opposite of this and divide by whatever is in front of that coefficient. Cool or not cool? All right. That's if you're doing algebra. If you're doing pre-cal, like we're doing right here, so then you can write this. Let me show you a pre-cal. 2 sine x minus 1, close, sine x plus 6, close, equals 0. That means that sine x has to equal -6. That will never happen. Put a slash through the equal sign. But this one over here will happen. Where does sine x equal a positive half? I draw a unit circle, and I'll wait for you guys to catch up. Sine is a positive half in quadrant 1 and in quadrant 2. What are those radians? Pi over 6 and 5 pi over 6. OMG. Don't worry, I'm going to upload this. I'll upload this video as soon as class is... How much time we still got? What time is it? Are we out of here? Oh, yeah, we got plenty of time. You know what? Let's say some time. Question 9 is exactly like question 8. Is it cool if we skip question 9? Yeah, because it's exactly the same. Okay, question 10. Yeah, you guys have issues with squares because I saw that on Delta Math. So I do look at the data, guys, to make sure that try really hard. I know some of these can be done with Math Type or Math Way or something like that. Try really hard to, because you're not going to be able to use those apps when you take a test on Wednesday, guys. So make sure, I mean, you can use them to check your work, but I would really make sure that you know what you're doing. Divide both sides by 4. So then we have cosine squared x equals 3/4. And then how do I get rid of that square? Square root. So now I have cosine x, and then use your law of exponents. That means square root of 3 over square root of 4. So then I'm going to write cosine x equals, and then the square root of 3, leave it alone. And the square root of 4 is 2. And I notice that I put the plus minus there. -2 times -2 is 4. Positive 2 times positive 2 is 4. So now you ask yourself, where is cosine square root of 3 over 2? Both positive and negative. All of these. The denominator is 6 in all of those. So you look for where the denominator is 6, and you need all 4 of them, so it's this one. Is that making sense, guys? You can come in. All right, here we go with the next one, guys. Do you guys want me to do that one? It's similar to a question we did earlier, but we can do it really quick. Yes or no? Yes, okay. Move the cosine x to the left. Cosine squared x plus cosine x equals 0. And then we're going to factor out a cosine. So here's the cosine x factored out. So you're going to have cosine x plus 1. Okay, this one you're going to have 2 unique answers. So it's better to do it like this. The only way to get a 0 is if cosine x is 0. Well, there's another one. We'll talk about the other one right now. On the unit circle, where is cosine x 0? Perfect. At pi over 2 and at 3 pi over 2. So those 2 are going to be answers. But now look, you're going to have a unique answer right here. Then you do this inside expression. Cosine x plus 1 equals 0. I move the 1 to the other side. Where is cosine x equal to -1? At pi. Yeah, perfect. So those are your answers. So look for pi over 2, pi, and 3 pi over 2. Cool or not cool? Cool. Go to the next one. Question 12 is exactly like question 11. Is it okay if we skip it? Okay. Okay, we'll do 13 because I saw sometimes on Delta those give you issues. Okay, so I'm going to do the Ruiz method. They like to, as soon as they see cosecant, they like to turn that into sine, which I actually like. That's actually the preferred method. So I'm going to turn that into a sine. I'm going to write sine 2x equals a -1/2. I just took the reciprocal. And before I do it, well, I guess we can do the arc sine. So write 2x equals arc sine of -1/2 plus 2 pi n. Here's my unit circle. On the unit circle, sine is a -1/2 in quadrant 3 and in quadrant 4. In quadrant 3, what's my radian? Yep. So I'm going to write 2x1 equals 7 pi over 6 plus 2 pi n. What about the one in quadrant 4? Perfect. So there it is. I'm doing a different color to indicate the other one. 11 pi over 6 plus 2 pi n. And then the period's actually pi on that one. So, right, okay. Divide by 2. So divide by 2 or multiply by times a half. I think that's what you guys prefer. Multiply by half. So now you get this. x1 equals 7 pi over 12 plus pi n. And then on the x2 one, times a half, times a half. So let's see what we get on this one. x2 equals 11 pi over 12 plus pi n. Okay, so catch up. You're going to get 4 answers because I'm looking between 0 and 2 pi. My first answers are obviously these right here, 11 pi over 6 and 11 pi over 12. Wait, hold on. Did I do that right? 7 pi over 12 and 11 pi over 12. Sorry, guys. 7 pi over 12, comma, 11 pi over 12, comma. The next answers come from adding pi. So, Chav, how do I do it when I have a denominator of 12? Just make it 12 over 12. Is that making sense to you guys or no?
Yes.
Okay. What is 12 plus 7? There it is. That's another one. 19 pi over 12. Let's go to the one in sky blue. Do the same thing. Sorry, guys. 12 pi plus 11. 12 pi plus 11 pi. What's that? There it is. Sorry, YouTube. I'm usually censored. I was censored. I didn't say anything. I didn't say nothing. Is that a double negative? When every time people say that, I always think like that's a double negative, right? I didn't say nothing, so that means you did say it. So when someone comes to you and say, "Did you tell blah blah blah?" I'm so mad. Did you say? I didn't say nothing. Like you're telling them the truth, right? You're like, yeah, I did. I didn't say nothing. Like double negative. You did not say nothing. But people say that all the time, right? Like I didn't say nothing. Like okay, I'll stop. Hey, Grajeda, if you're watching this, let me know if that's a double negative. If I didn't say nothing really means that you said something. Okay. You know what? I'm going to send this video to Grajeda and tell her to go to this timestamp. All right. Question. I think we're getting pretty good at solving equations. Do you guys want me to do question 14? Okay. Arc sine both of them. So x plus pi over 4. I guess it's a little different because I have a plus in there. Equals arc sine of negative square root of 2 over 2 plus 2 pi n. So do that. And then I'm going to do this first. I'm going to write x1 plus pi over 4 equals, on the unit circle, sine is negative square root of 2 over 2 in quadrant 3 and in quadrant 4. What is it in quadrant 3? Perfect. 5 pi over 4 plus 2 pi n. And I'm going to change my color here. So there is a good one for colored pencils. x2 plus pi over 4 equals, the other one is? Perfect. I go back to the one in red. I got to get x1 by itself. So this one, I got to subtract the pi over 4. Do you guys see that? So x1 equals, I'm going to subtract. I'm subtracting 1 pi over 4. So 5 pi over 4 minus 1 pi over 4 is 4 pi over 4, which is the same thing as pi plus 2 pi n. And then I'm going to go back to the sky blue. x2 equals, I'm subtracting, 7 pi over 4 minus pi over 4 is 6 pi over 4. So I guess I'll write that down first. And then I know that 6 pi over 4 reduces to, it reduces, they're both even, 3 pi over 2. All right, they want all the answers between 0 and 2 pi, so I'm not going to add 2 pi to them. So that means my answer has to be, where are you, pi and 3 pi over 2. How do we feel, guys? Okay. Do you guys want me to do number 15? No. No? It's the same. It really is the same as 14.
Yes.
Yes? Okay. All right, here we go. First thing I do. What's the first thing I do? Arc cosine. Arc cosine a half plus 2 pi n. And then you stop right here, because a lot of you are trying to do fancy stuff. Stop right there. Draw a quick unit circle or reference a digital unit circle or reference your notes. Where is cosine a half? In quadrant 1 and in quadrant 4. What is the one in quadrant 1? It's not pi over 6. pi over 3. So I write x1 over 2 minus pi over 4 equals pi over 3 plus 2 pi n. And I'm going to change my color and go to sky blue. x2 over 2 minus pi over 4 equals, what's 1 in quadrant 4? 5 pi over 3 plus 2 pi n. All right, here we go. I'm gonna go back to the one in red here. I move the pi over 4 first. So I'm gonna write, let's see, do I have enough space? Yeah, I'll write it down here. I'm gonna write x1 over 2 equals pi over 3 plus pi over 4 plus 2 pi n. And I'm gonna do this right here. You can use a calculator, but I'm gonna do that right here on the side, guys. So pi over 3 plus pi over 4, I need a common denominator. I multiply this sucker by 4 over 4. I multiply this sucker by 3 over 3. And here's what you get. 4 pi over 12 plus 3 pi over 12. 4 plus 3? So 7 pi over 12. So I write x1 over 2 equals 7 pi over 12. Dang it. Plus 2 pi n. Last move. How do I get x1 by itself? Times 2 times 2. So now I have x1 equals 14 pi over 12. It's going to reduce. Plus 4 pi n. And then I reduce that. So x1 equals 7 pi over 6 plus 4 pi n. Notice that 7 pi over 6 is in there. And it's that answer. I guess when you do the other equation, it's going to be a number outside the domain. Cool or not cool? So we pretty much finished it almost. The others are just questions like that, guys. Did we know enough to get it done? Did this help? Okay. All right, guys, we're done. Have a good day.